118 elements, each made up of its own unique atom, and names sometimes a little difficult to pronounce, and one element so dangerous that scientists hypothesize that this size, dropped into the ocean, would create this. From previous lessons, we have learned that all matter is made up of molecules and that molecules are made up of atoms. And that everything that appears on the periodic table is a pure element. It cannot be broken down any further. It consists of one singular atom. Let's take a look at this atom. So the atom consists of three main parts: protons, electrons, and neutrons. Electrons are the little ones that fly around the outside, and they are negatively charged. And in the middle, in a nucleus, is the protons and the neutrons. Protons are positively charged, electrons are negatively charged, and the neutrons, well, they're just neutral. Okay, so it was a Russian chemist, Dmitry Mendeleev, in the early 1800s who was the first to arrange the elements into the pattern that we know today. In fact, he even inserted himself into the periodic table, element 101, Mendeleevium. So why does the periodic table look like it does? Well, let's go back to term 1. Carl Linnaeus came up with a classification pyramid in order to classify all living things according to their characteristics. Well, Dmitry Mendeleev did the same with the elements. He arranged the elements according to their properties. He realized that in this arrangement there were patterns of repeating properties. Scientists did not discover all the elements at the same time. Some elements were discovered quite recently. However, even though some elements had not yet been discovered in the 1860s, Mendeleev still knew to leave blank spaces for these in the table. So boys and girls, this is really not that difficult to read. Looks a bit daunting to start off with, but let me give you a little bit of an explanation. You'll understand a bit more what I'm talking about. Right, so in order to read the periodic table, you need to understand it is split. Three main parts: metals, non-metals, and semi-metals. The easiest way to figure out the periodic table, find this cross. And you will see it is a thick line that runs down, almost like a staircase. Right, there's the staircase. Now everything, those dark green ones on either side of the staircase, are my semi-metals, or commonly referred to as metalloids. Okay, they have properties of metals and properties of non-metals, so therefore they're semi-metals. All of those to that side of the staircase are non-metals, which includes things like noble gases and halogens, and then everything this side of the staircase is a metal. Different types of metals, but metals nonetheless. Now luckily for us, the periodic table is broken down into columns and into rows. We call these columns groups. There are 18 of them. These columns or groups run down all the way up until 18. And the periods or the rows run horizontally, and there are 7 of them. You know what happens in this spot here? We haven't just left them out. If you look at the numbering here, you will see it goes 55, 56, 72. Okay, not that confusing. You see this at the bottom? Watch their numbering. So here I have 55, 56, there's 57, 58. So these two at the bottom, I have taken this whole 2 rows or periods, squash them together, and they go in there. Okay? If you watch the periodic table song, you will notice they explain it quite nicely. It is just to separate the lanthanides and the actinides, although they fit into these. Remember, 18 groups and 7 periods. Therefore, this row of actinides becomes part of period 6, and this row of lanthanides becomes part of period 7. Now we've labeled these things and numbered them so that they're easy to find. Here's the kind of question you can expect. What element can be found in group 11, period 5? So all I need to do is find group 11, because we know my groups run down, and I need to find period 5, and I use my fingers, and I get to element 47, silver. And I know that silver is a metal because it's this side of the staircase. Let's practice another one. What element can be found in group 15, period 6? Right, so let's find group 15, period 6. I run my finger along, and I run it down, and it's element 83, bismuth. Right, bismuth still falls into a metal because it is this side of the staircase. Let's find a non-metal in group 14. So I have finding group 14, the only non-metal I can find in group 14 is carbon, because silicon and germanium are semi-metals, and tin, lead, and fluorobium are metals. So you have to understand this staircase. Guys, I've given you quite a few activities to do on this periodic table, just getting to know it and finding the elements. When we meet up on Teams, we will go through this with any questions that you have, but practice makes perfect when it comes to the periodic table, especially trying to find, understand, and locate different elements using groups and periods. Okay, let's take a look at the layout of an element as it appears on the periodic table. Start with the easy things. This here is the chemical name, and this here is its chemical symbol. You will notice throughout the periodic table that if the element has got two letters, the first one is always uppercase and the second one is lowercase. If there is only one letter, it is always uppercase, and that helps when we start writing out equations. So what are the other two numbers? Well, this number here, if you look at the periodic table, that shows you its position. It's number 4 on the periodic table. But not only does that show you its position, that actually shows you how many protons this element has. Remember what I said, each of these elements is an atom, and each atom consists of protons, electrons, and neutrons. But each of the elements on the periodic table have its own configuration of protons, electrons, and neutrons. Now, if you remember as well from previous lessons, if we have 4 protons, right, we will have 4 electrons. Those always equal each other. So what then is this number? This here is the atomic weight of the element. So we know it has 4 protons, we know it has 4 electrons. Nowhere does it tell us how many neutrons it has. It's easy enough to work out. If its weight is 9, and we already know we have 4 protons, then all we have to do is take its atomic weight minus the amount of protons, and we will come up with the amount of neutrons. So this element, as it stands, beryllium, has 4 protons, 4 electrons, and 5 neutrons. And that is how you work out an element's atomic configuration. Right, let's do another element quickly together. Okay, oxygen is its chemical name. Capital O is its chemical symbol. It is position number 8 on the periodic table, which means it has 8 protons. It has an atomic mass of 16. Let's work out the neutrons together. So we have an atomic weight of 16. We minus the amount of protons, and we come up with 8. So in other words, this symbol has got 8 protons, 8 electrons, and 8 neutrons. Boys and girls, practice makes perfect with this. I've given you quite a few activities in order for you to practice all of these things. Go through the periodic table song a few times. Pay careful attention to how the chemical symbol is written, first in uppercase and then the lowercase. And just practice. Enjoy. We'll meet up on Teams and go through any questions that you may have.